Hello and welcome to our lesson on adding whole numbers. So the process of finding the sum of our whole numbers is what we call addition. I'm sure we've all seen addition sometime or other. And basically to add whole numbers, if we did not have a calculator, we would add the digits that are in corresponding place values, something we talked about last time. Okay, in place values. And if the sum of our digits in those corresponding place values happens to be more than 9, then we may have to do some carrying over to the next set of digits, the next place value. Okay, so for example, if I said to add 2,236 plus 160, we're going to line this up where 2,236 and 160, the digits line up, so the ones place, tens place, hundreds place are all aligned. Okay, and then it's just addition. And luckily, we have enough fingers to do most of this addition here. So 6 plus 0 is going to be 6 here. And then we're going to add in the tens place the 6 and the 3, which makes 9. Then we're going to add in the hundreds place the 2 and the 1, which makes 3. And then there isn't anything to add in the thousands place, and so the 2 is just going to come down. And that's that. So that is our answer, 2,396. So 2,390, not and, sorry, improper to say and, 2,396. And fortunately, if we had a calculator, we could verify this. So just want to show you, since we didn't get to use it last time, this is Desmos. This is the app that I mentioned in the orientation for the course. If you want to download it, it would probably come in handy throughout the course of the semester. If you don't want to download it as an app or don't have the capability to do that, you can also access this calculator at www.desmos.com, but it's really user-friendly and it's free. So if you don't already have a calculator, this is a great option for you. So let's just verify that we did this correctly. 2,236. If we add to that 160, boom, there it is, 2,396. Okay, let's try that again. So if we were going to add 23 with 136, I would start with 136 and then line the 23 up. So again, the ones and tens places go together. 6 plus 3 is going to give us 9 here. 3 and 2 in the tens place makes 5 in the tens place, and there isn't anything to add to the 1 that's in the hundreds place, so that 1 can come down. And so 23 plus 136 is 159. And I could box that in. Let's make it official. Okay. Now sometimes we have to carry, and let me show you on this one. For example, if I had to add 365 and 89, when I line up these digits, adding the 5 and the 9 makes 14. Well, I can't put two digits in one spot. So I'm going to keep the 14, right, that we get. The 4 is going to stay in the ones place. This is going to be an additional 1 to go into the tens place. So when we carry, it looks like this. The 4 in the ones place, we're going to carry the additional 1 into the tens place. So now we're going to add all those digits up in the tens place. So we have 8 and 6 is 14, plus 1 is 15. Again, 15, that's in the tens and hundreds place. The 5 can stay where it is in that tens place, but the 1 is going to have to carry over to the hundredths place. And so now the 3 can be added to that 1 to make 4. So we end up with 454 for our sum. So our sum is 454. And again, this would be nice to verify with the calculator just to make sure I didn't goof anything up here, right? So 365 plus 89 makes 454. Okay, so addition, not so bad. A couple properties we're going to see. Well, the first one actually already came up in one of our problems. It's called the addition property of 0. It just means that the sum of 0 and any number is the number. So adding 0 to any number will not change the value of that number. So no matter what our number is, for example, let's say it's 5, if we add 0 to it, we will get 5 every single time. Okay, so adding any whole number to 0 does not change the number. We will still get that number back. Right? Maybe that one doesn't seem so useful. The commutative property, however, is somewhat useful. The commutative property of addition, and it actually also applies to multiplication, but for addition, the commutative property says that changing the order in which we add does not change our sum. So for example, let's say I wanted to add 3 with 7, and then change the order to add 7 with 3. Well, 3 plus 7 makes 10, and 7 plus 3 also makes 10. So even though I change the order, it does not change the sum. That's going to be true every time. That is what we call the commutative property of addition. We can change the order in which we add and not change our sum. Okay? And then we have something called the associative property of addition. The associative property of addition says that we can change the grouping of numbers. We can change the way we group our numbers in an addition problem, and it will not change the sum either. So for instance, let's say I had 1 plus 2 plus 3, and I grouped the 2 and the 3. Well, if I added the 2 and the 3 here to make 5, and then went and added the 1, I would have a result of 6. Well, let's say I changed the grouping. Instead of grouping the 1 or the 2 and the 3, I grouped the 1 and the 2, and then added the 3. Well, the 1 plus 2 here would be 3. If I go and add the 3 on the outside, I still end up with a result of 6. So changing the grouping is not going to change the sum. These are going to be equal every single time. And again, that is what we call the associative property. I can change the numbers that I group together in an addition problem, so it relates to changing the order and not change the sum. Okay, so here's a problem where I might use one of the properties. So here, number 4, we're asked to add 13 to 7, 8, and 9, and I can really add in any order. That's what the commutative property says. Or I can even group numbers together and then add. So if I was looking at this problem, I would probably group the 13 and the 7 together, because 13 and 7 makes 20. That's an easy sum for me to look at. I would also probably group the 2 and the 8. The 2 and the 8 makes 10. Again, that's another easy sum for me to look at. And then I would look at the plus 9 that's left over. So adding these 3 seems a little less daunting than adding the 5 that we started with. So 20 and 10 makes 30, and then 30 plus 9 makes this sum 39. So our sum is going to be 39 altogether. And again, you could verify that with a calculator if you needed to, but here you can see how those properties kind of come in handy. Okay? So you're allowed to do that. All right. Let me show you a couple of applications of addition, some places where you might have to apply that process. A couple of them might be with finding the perimeter for a polygon. That's our fancy geometry word for a shape. Okay, so this polygon has 4 sides. If we're asked to find the perimeter is the distance around the outside of our polygon. So to find perimeter, we're simply adding all of the sides. We add the sides, add the side lengths. Okay, so in this case, our perimeter, let's call it P, is going to equal 5 centimeters plus 7 centimeters plus 4 centimeters plus 3 centimeters. So I've got the 7, 5, 4, and 3, all of those captured in there. Now if I add all of those up, again, it doesn't matter what order you do this, I would probably look at the 7 and 3. Again, that makes 10 centimeters. And then if I group together the 5 and the 4, that's 9 centimeters. And if I now put together the 10 and the 9, I end up with my perimeter being equal to 19 centimeters. So the perimeter is 19 centimeters all the way around that polygon. Okay. Now, if I give you a problem like this in Canvas, just so you're aware, it's not going to accept the units when you input the answer, unless it was multiple choice. But if you're inputting the answer, you would just put the 19 without the centimeters. Okay. And I'm not so worried about the units anyway, so let's try another one. We're trying to find the perimeter here by adding these side lengths. So this time is 7 centimeters plus 8 centimeters and 13 centimeters. So the perimeter this time, if we put together, let's see, 7 and 8, we end up with 15. And actually, maybe you were seeing this too. These make a nice 20 here. That's probably a better grouping. Those 20 centimeters plus the 8 centimeters makes a nice 28 centimeters. And it doesn't matter the order you add, so if you didn't see that grouping and just did 7 and 8 to make 15 and then added the 15 and 13 to make 28, you're going to get the same thing. So kind of whatever's jumping out at you. Okay? Alright, how about this next one? Number 7 here, it says that in 2015, a total of 9,800,000 879,465 trucks were sold in the United States. That's a lot of trucks. And then in 2016, the very next year, it says that total increased by 712,397. So if we increased by, that increased by is telling us it went up by, we would have to add to that total 712,397. So if we want to find the total number in 2016, we are going to be adding the 9,879,465 with the, not enough space there, with the 712,397. And so let's put these together. So 5 and 12 in the, or 5 and 7 in the ones place makes 12. So the 2 is going to come down, the 1 is going to carry. And then 1 and 6 is 7. 7 and 9 in the tens place makes 16. So we're going to have a 6 there. We're going to carry the 1 again. 1 and 4 is 5. 5 and 3 in that hundreds place is going to make 8. And then in the next column, nothing to carry over, so just 9 and 2, which is 11. So 1, carry the 1. 7 and 1 is 8, plus another 1 makes 9. And then nothing to carry, so just 8 and 7, which is 15. So we're going to put the 5, carry the 1. And then lastly, 9 and 1 makes 10. So if we put the 0 and carry the 1, that would put a 1 in that 10 millions place. So we had almost 10 million in 2015. That increased by 712-ish thousand. So if we add that number, that means in 2016, 10,591,862 trucks were sold. I don't know if that's a true statistic. Kind of read that one and found the problem in a textbook, so could be true fact, probably. It is old data either way, but there it is. All right, one last one. It says the children in a kindergarten class were surveyed about their favorite type of fruit, and the results were recorded in the bar graph that we see pictured here. According to the bar graph, how many children were surveyed? So reading this bar graph, let's see. First, children that said apples are in this first bar. And since the first bar goes all the way up here to 4, there's 4 children that surveyed, that answered apples. That's 4 children that are in the survey. The banana bar goes all the way up to 8. And it says pears goes all the way up to 5. Grapes all the way up to 6. Oranges, we've got 2. Plums, I wouldn't have expected any kindergartner to say that. We got 5. And then peaches, only 1 student. So if we want to find the total number of students in the survey, we need to add all of those responses. So we're adding 4, 8, 5, 6, 4, 8, 5, 6, 2, 5, and 1. And again, we can go left to right with this, or you can look for groupings that are kind of helpful, like the 5 and a 5 are jumping out to me. They're going to make 10. And also jumping out to me, we've got, let's see, 4 and 6. There's another 10. And then I can also see here 8 and 2 makes another 10. And all that leaves us is 1. And that's really not too tough to add. So 10 and 10 is 20. And another 10 makes 30, plus the 1, which, let me change that color there. Plus the little leftover 1 makes 31 our sum. So we're going to say 31 children were surveyed. Okay, hopefully it hasn't been too long since you actually added whole numbers. And hopefully this is just a nice, easy refresher for you. So you've got some problems to work on in your practice assignment. And as always, if you find yourself struggling or needing some extra help, then just reach out. All right, take care.